If you think about the core processes of digital transformation, representation, connectivity, aggregation, it's quite clear that aggregation is somewhat disproportionately important. Putting all that digital information together and extracting intelligent insight from it, this is where a lot of the action today is. And there's no doubt that the most transformative technology that does this is artificial intelligence or AI. So I want to give you a very quick overview of what AI is all about and an intuitive understanding of how to think about this set of technologies that come under the label of AI and why they're so important. Firstly, AI is not new. The field of artificial intelligence has been going around for at least half a century, maybe more, and can be traced back to a very important conference held in the 1950s. But what has changed in the last decade, about a decade and a half or so, has been the kind of AI that we currently have. This is called machine learning. So, the best way to understand the difference between this modern AI, which is machine learning based, and old AI, which is called rule based AI, is to think of the following example. Suppose you had to teach your child how to do long division. Okay, you have a 10-year-old and he's learning how to do long division. How do you do it? Well, you write down the steps, you explain the rules, and you walk them through each of the rules, and hopefully they understand the rules, and then they can apply it to do any long division problem they face, right? Now, contrast that with teaching the same child, the same 10-year-old, how to ride a bicycle. I can't give you rules on how to ride a bicycle, right? You have to figure this out yourself. What you can give them is lots of experience. You can show them through example and you can help them develop their own examples by trial and error from which they can learn their own rules, which are tacit. They may not even write these rules down anywhere. They might be there somewhere deep in their mind. But what they're doing is using their experience to infer the rules from the data. That's machine learning. All machine learning today, from the least sophisticated to the most cutting edge technology, all operates in a fundamental sense in the same way. And that way is essentially about learning rules from data. Okay. An analogy that might help you see it even more clearly is think back to those high school problems and questions that we used to get in exams where they show you a series of shapes, a circle, a triangle, a star, a circle, a triangle, and then a question mark. What's coming next? That's the question, right? So how do you solve this problem? You do it by inferring the pattern from the data. So the rule here is circle, triangle, star. You've seen a few examples, you can figure out that's what the rule is. So when you get circle, triangle, question mark, you know what's coming next is a star. This is exactly how modern machine learning works, regardless of how sophisticated it is. There are some technical bells and whistles, which I won't get into here, but the gist of it is given enough data, if there's a pattern in the data, we now have machine learning technologies that can find that pattern. The pattern could be probabilistic, it doesn't have to be a deterministic pattern. So it could be with some probability it will be a star rather than it's always a star. But if the pattern is in the data, the algorithms can find it. And if they can find it, they can use it to make a prediction. So all modern AI is machine learning. All machine learning works as a prediction machine. That's why I sometimes call it an imperfect crystal ball. So modern machine learning is like an imperfect crystal ball. It's like a crystal ball. It forecasts, it predicts, okay? But it doesn't get it right all the time. For a variety of reasons, the most obvious simply is the quality of the data we feed it. So the better the data we give it, the better the pattern in the data, of course the crystal ball gets that much more powerful. But at the core of it, all machine learning is driven by the same underlying logic. Given a lot of data, given a lot of processing power, if there is pattern in the data, the algorithms can find it. Once I've found the pattern, I can use it to make predictions, exactly like my triangle, circle, star problem. So I can see what's coming next. And that ability to make predictions is enormously important. Now, why is that? Think about this for a second. Every decision you ever made in your life, whether it's buying a car, buying a house, whom to date, which job to take, each of these decisions actually rests on a prediction. You may not have thought about it explicitly like that, but in reality, that's what it is. So every decision between doing A and doing B relies intuitively on a prediction you're making in your mind about what will happen if I do A, what will happen if I do B. Now, if you can use machine learning, modern AI, with a large amount of data and a lot of processing power to improve the quality of that prediction, what will happen when I do A, what will happen when I do B, then of course your quality of decision making will improve. That's the core of why machine learning today is so important, so exciting in business applications, commercial applications, technical applications. if there's a decision that needs to be made, which can be anchored to an underlying prediction problem. And that prediction problem can be solved by using a lot of data in which there's a pattern that can be discovered. Then, even if our human minds can't discover that pattern, the algorithms can. That's what makes machine learning so incredibly powerful. Now, you might be thinking about latest developments in AI like large language models or ChatGPT. How is that different? Fundamentally, it's not. ChatGPT and large language models also work in basically the same way. What they do is using a large amount of data, which in this case is the volume of text in various book libraries in the internet, the algorithms can find patterns in language. So it turns out that the way we speak, though every time we say it, which sounds to us like we're being very creative and novel, there's actually a lot of pattern and structure in what we say. To the extent that, given enough data and given a few words, an algorithm can actually predict what are the next few words that will come, exactly like our triangle, circle, star problem, right? So, given enough data, given enough computing power, algorithms can detect inside those data sets these probabilistic patterns of what language comes next. And that's exactly what large language models like GPT 3.5 and GPT 4 are doing. So, you put in some text, and what the algorithm is doing is predicting what's the next set of text that would be most appropriate given the text you fed in. Okay, that's roughly what's going on. Now, of course, even though the principle is the same, large language models have really been revolutionary because for the first time, these predictions look and sound like humans. So they talk to us like humans would do. They answer questions, they synthesize ideas, they search, they put together ideas from disparate domains and integrate them. So it really is quite a remarkable breakthrough in terms of the outcome. My point, however, is the underlying logic of how it works is always going to be driven by the same approach in machine learning, which is given enough data and given powerful processing technologies like deep learning architectures. We needn't get into the technical details. If we can find that pattern in the data, we can convert it into a prediction, and that prediction in turn can then be used to make lots of economically important decisions.